Hello everyone, welcome to my YouTube channel Shivam Codes. Today I will be talking about memory layout in C++. I'll be going in depth how memory is allocated for any C++ program, and I will be explaining this with visual representation. So to begin with, what consumes memory? So it is the process. A process consumes memory, and a process is nothing but a program which is acting as an active entity rather than a passive stored file. So a process is nothing but a program which is executing. So a program, when it is loaded into the memory and it is executing, then it becomes a process. And a process consumes memory since it is loaded in the memory. Now I will be going over the memory layout of a typical C++ program. So let's say we have this RAM allocated to us. This is the memory chunk that we are getting for our C++ program or any C program. So what does these higher address and lower address actually mean? They literally mean that they are higher address and they are lower address. Now, what I mean by that is the lower address are actually having lower address values because this is RAM is nothing but a memory pool, right? So a memory has to have an address. So the bottom part of the memory that we have has lower memory address, and the higher part to the very top, we have memory, which has higher memory address. Now, we won't be needing that in our further explanations, but I wanted you to make sure what the higher address and lower address means. Typically, there are two sections in the memory layout of any C++ program. That is data section and text section. The data section is further divided into dynamic and static data. The static data is then further divided into uninitialized data section and initialized data section. Also, the dynamic section is also further divided into stack and heap. Now, this is the exact memory layout of any C++ program or C program. This is exactly how it looks. The heap grows upwards, the stack grows downwards. Now, what I mean by when it grows upwards and something grows downwards, what I mean is this is a memory block that is allocated to us. And as we keep consuming it, the blocks will be filled with some data. So we have to move upwards in heap to consume more memory. And we have to move downwards in stack if we want to consume more memory. And there will be a time when the stack and heap, they will collide. That is the case when we run out of memory. Now, what does text segment mean? So text segment is also known as code segment, and it contains executable instructions for any program. And since it is shareable, it is a read-only. We cannot write to this text section. Even the string literals that we have in C++ are stored in this text segment. Moving on to initialize segment. This initialize segment contains global and static variable. So both global and static variable are stored here, but they have to be initialized to be stored in this section. And it is not read-only and it can be modified. Moving on to uninitialized section. This is usually called the BSS segment. Data in this segment is initialized to 0 by kernel before program starts executing. So when we have any static or global variable that is uninitialized, it will be stored in this section. And you must have noticed, if you have written C++ code before, that any uninitialized static or global variable are by default initialized with 0. Now that happens because the kernel does that. The kernel initializes it with value 0. Moving on to heap. Heap is dynamically allocated memory, which is allocated via new or malloc keyword. And there is one very important thing, which is that the memory that we allocate in heap has to be freed by the programmer. Moving on to stack. So the variables declared inside the function are stored in the stack. So any local variable declared inside a function is given the space in stack, which is this section of the RAM. Now, Here I have a sample program and I will be going over where these variables are stored in the memory. So let's go over it. The first variable is G1. Since it is a global variable and it is uninitialized, so it will be stored in the uninitialized section of the RAM. Then now the next variable is G2. This variable, since it is static and uninitialized, it will be stored in the uninitialized section with value of 0. Since we already know this 0 is coming because the kernel gives it value of 0. Moving on to G3, this value is also global, but since it is initialized, we will be storing this in the initialized section. Next is the G4 variable. Since G4 is a static variable and it is initialized, it will be stored in the initialized section in the RAM. Next, moving on to the main function, which is the L1 variable. So since the L1 variable is stored inside a function, which is the main function, this L1 variable will be stored in the stack. Next is we have a pointer, and that pointer is storing some dynamically allocated memory because we have used the new keyword. So there are two things that happen here. First, there will be space allocated in the heap, and the value that I have written here is the dummy address value that I'm assuming this block will get. This block will have some garbage value, and let's assume that the address of this block is 100. The next thing is the new int keyword will allocate some memory in the heap, as you can see in the image. Now it will return the address of this memory block into the L2 variable. And since the L2 variable is written inside a function, it will be stored in the stack. And it will also point to that memory location which we have just created in the heap. Since that address is 100, the L2 variable or the L2 pointer is having that value. Now, when we dereference the value of L2 and we store 10, what we are essentially doing is we are dereferencing the L2 value and then storing the value. So we are putting the value of 10 in the heap. Since the address of this block is 100, now we have stored the value of 10 inside this block. And that completes the execution of this program. Now I have a quick question for you. You should pause the video here and try to figure out where the value of A and B will be stored. So now I will be explaining where these value will be stored. Most of you might think that since it is written inside the main function, it will be stored in the stack. But that is not true. Since it is a static variable, it will be definitely stored in the static section without a doubt. And it is initialized, so it will be stored in the static initialized section. It does not matter that it is inside a main function or any function. Static variables do not have local scope. It is a very important point. Static variables have their life throughout the program until the program stops the execution, just like global variables. And now you exactly know the reason behind it because it is stored in the static section or the global section. So because of that, it has scope throughout the program. Now, there is one more variable, static int b. Since it is a static variable, it will 100% be stored in the static section of the RAM, but it is uninitialized. So we will be storing this variable in the uninitialized section. And since kernel allocates 0 value to uninitialized variables, hence we will be having value of 0. So that is it for the video. I hope you guys learned something new today. If you did, make sure to like, share, and subscribe, and I will see you in the next one.